Good afternoon, everyone. This is spring semester of 2020, College of the Sequoias in Central Valley of California. This class is College Algebra, and in this section, we're starting to discuss systems of equations. So chapter 9 is on systems of equations. And this is where, if you've hopefully seen this before in an algebra class, systems of equations is when we try to solve, when we need to solve more than one equation simultaneously. Okay. So let's just go over some of the basic methods we've had. This first section is 9.1. Start there. And these are the fundamental operations. So solving systems of equations. It's a good old-fashioned way. One option we had was using substitution. Option A is the substitution method. And this method is ideal when one of the coefficients is 1. Okay. So let's take a look at it. Let's just set up our first example. Our first example, we have two equations. Our first equation is going to be 4x minus 3y equals 14. And our second equation is going to be x minus 2y equals 1. We need to solve these simultaneously. Okay? So a solution to a system, I'll put this at the bottom. A solution to a system solves both equations. A system of equations solves all equations in the system. In the system. So this is what I meant with the substitution method. Right now, if we look at our coefficients, we've got a 4, a -3, a blank, and a -2. A blank is always a 1. We can solve this equation for x. So let's solve this one for x. We're going to do that. We'll do the opposite of subtracting 2y, which is adding 2y. And we get x equals 2y plus 1. This x is identical to this x. Same x. So we're going to take it and we're going to plug it in. And when we do that, we have 4. I'm keeping the rest of the equation the same. And I'm just plugging in this 2y plus 1. I'm replacing or substituting x with 2y plus 1. Now, this is an equation with a single variable, and we can solve for it. How do we do that? Well, we distribute. 4 times 2y is 8y. 4 times 1 is plus 4. I'm going to subtract 4 in the same step. I'm going to combine like terms just to save some room on this page. 14 minus 4 is 10. 4 minus 4 goes away. 8y minus 3y is 5y. Divide by y, or 5, and we get y equals 2. That's part of it. Now we're going to take that and plug that in there. I have x equals 2 times 2 plus 1, so x equals 5. The solution is the point or coordinate 5, 2. And what does this really represent? Let's take a look at this in Desmos. So I have two equations. We have 4x minus 3y equals 14. I should say 3y, not 34. And we've got another equation, x minus 2y equals 1. So what is going on here? Well, each of these is a line. Every point on the red line solves 4x minus 3y equals 14. Every point on the blue line solves x minus 2y equals 1. The only point that is on both lines is where they intersect. And look at that. 5, 2, which is what we have over here. So the solution to a system of equations is where the lines intersect, where the lines or curves and we could graph this by hand if we wanted to, but it's there in Desmos. That's one method. Let's take a look at an option and an alternative method. Option 2 or option B. I think I used A on the first one. Yeah, I used A. So let's call this option B. This is called the elimination method. And this is useful when none of the coefficients are 1. And can't be made into a 1 using division, of course. That's how we would get a coefficient of 1. Like if we had a 4 in front, we could divide by 4, but we can't make it into a 1 without introducing fractions somewhere else. And working with fractions is lame. It slows stuff down. The main goal in the elimination method, make the coefficients for one of the variables equal but opposite. For example, (2x plus y equals 1), negative 2x, well, let's 2x plus 3y, let's do that. Negative 2x plus 4y equals 6. These coefficients are equal but opposite. Okay. And the way we accomplish this can be accomplished, can be accomplished by multiplying the equation one or more. Sometimes you can get away with just multiplying one of them. So I'll put the S in parentheses by a number that makes them equal and opposite. Equal but opposite. Something that always works. What always works use the coefficients of the other equation. Use the coefficient for the variable of the other equation. But make sure one ends up negative. Another name that you'll see for this method is called the addition method. And so it's referenced by several things. You'll see why when we do our example. You ready for one? Okay. So we've got 2x plus 3y equals -1. 3x minus 2y equals 18. And what we should ask ourselves is, which variable should we focus on? It's personal preference. So I'm going to go through and choose the one I would choose here. At the end of the problem, I'll give you some ideas on how you can help decide which one you want to focus on. So I can either try to get the x's to have equal but opposite values, or I could get the y's to have equal but opposite values. What motivates my choice right here is that the y's are already opposite. So this is my idea here. Y's already have different signs. One's positive, one's negative. So it's easier to focus on how to do the multiplication. What I'm going to do, this is a 3, that's -2. I'm going to multiply this entire equation by 3. And I'm going to multiply this entire equation by 2. Now, what happens when I do that? 2 times 2x is 4x. 2 times 3y is 6y. And don't forget to do the other side. 2 times -1 is -2. Can I do that? I can do that over here. 3 times 3x is 9x. 3 times -2y is -6y. And 3 times 18 is 54. Notice they now have equal but opposite values. +6, -6. So what I'm going to do is I'm going to stack them. And then I'm going to add vertically. 4x plus 9x is 13x. So what I'm doing is I'm adding the equations together. The 6y and -6y cancel each other out. And 54 minus 2 is 52. Finally, we divide by 13. And there's a very common thing that has 52 that's easily divided by 13. It's a deck of cards. There are 4 suits of 13 ranks in each deck. 52 divided by 13 is 4. We're not done. This is just one part. Plug this back in to one of the original equations. I tend to plug it in where it looks like the math is going to be easiest. So which one is it going to be easiest on? If I put it in here, 2 times 4 is 8. That's easy. This has got a positive coefficient. That's kind of nice. If I plug it in here, 4 times 3, that's also easy. It's 12. Here's a negative coefficient. I'm going to make a mistake more often with a negative coefficient than I am a positive one. So I'm going to focus on the one that has a positive coefficient. 2 times 4 plus 3y equals -1. Now I'll go through and solve. 2 times 4 is 8. Subtract 8 from both sides. And I get 3y equals -9. And then I divide by 3 and I get y equals -3. The solution is 4, -3. You know what? It's really easy to check. Pro tip, check them. If it works in both equations, then you know you have the right one. So this is my x value, that's my y value. In equation A, I have 2 times 4 plus 3 times -3. Does that equal -1? 8 minus 9 equals -1. Yes, it works in the first equation. Equation B, I've got 3 times 4 minus 2 times -3. Does that equal 18? Three times 4 is 12. -2 times -3 is +6. And 12 plus 6 equals 18. It solved both equations. And did you see how easy it was to check? You just plug it in and see if it gives you a true statement. If it doesn't give you a true statement, your answer is wrong. That's important. If it doesn't work, your answer is wrong. Don't force it. You erred somewhere or you made a mistake. Go back and find it. It's going to matter when you're building something or solving something that people depend on, and you do not want mistakes in there. I can't tell you how often I get when I have a test on this, students do it, the problem, make the slightest mistake. It's as simple as turning a plus into a minus. And they go through and they solve it, they get nice, pretty numbers, and they're even willing to check their work. And they check their work and they get to a point where it says something like 10 equals 4. And then they erase a little bit and they just stop and don't go back and figure it out. I don't know if they think they did the check wrong, but if your check doesn't work, either your check was wrong or your answer is wrong. So it's worth, especially like on a test, it's worth looking into this stuff. Okay. This is why we call it the addition method. We added the two equations. And it's also why it's called the elimination method. We eliminated y's in that process. So in fact, I want you to take a second and go through, let's do the same example again. You know what the answer is. And now this time, eliminate x. Go ahead and pause the video and work this out. We know the solution. We just found it. It's 4, -3. You'll know if you got it right because you got the right answer. Oh, you guys might enjoy this. I don't know if I can make it. It's too blurry. My birthday was this last Friday, and I went and got my birthday coffee, and it's a venti mocha with 4 extra shots. It's got 6 shots of espresso in it. I've been nursing it. I've been sipping it slowly because that's a lot of caffeine. All right, let's go through and solve this for x first. So I'm going to look at the coefficients on those letters, 2 and 3. I'm going to multiply the other equation by them. So I'm going to multiply the 2 by a 3, and I'm going to multiply this one over here by the coefficient over here, 2. But since they're both positive, I'm going to introduce a negative sign on one of them. It doesn't matter which one you introduce the negative on. So I distribute, and I get 6x plus 9y equals -3. And make sure you distribute the negative on all of them. -2 times 3x, I'm going to put it, I'll line it up underneath, is -6x. -2 times -2y is 4y. And -2 times 18 is -36. We'll add them up vertically. 6x minus 6x, they eliminate each other. 9y plus 4y equals 13y. And -3 plus -36 is -39. We divide both by 3, and we get y equals negative 13 or negative 3. Negative divide by 13, not 3. 13. There we go. And we get y equals negative 3. Then I'm going to go back and plug it in. I'll plug it into the first one again. 2x plus 3 times negative 3 equals negative 1. 2x minus 9 equals negative 1. Add 9 to both sides. 2x equals 8. And we get x equals 4. And our solution is 4, negative 3. Okay. So how I choose which variable to eliminate? Tips on choosing variables or choosing the variable to eliminate. One option, as I did in this one, use variables that already have the opposite sign. And then you just multiply by the positive version of the other's equation. Version of the coefficient of the other equation. That's usually one I go with, and unless it happens to be that they're really big numbers already. Like if I've got 9 and negative 17, I don't want to work with those numbers. Multiplying is going to make big coefficients and it's going to suck. The other option, if one variable has small coefficients, use it, but be sure to introduce a negative sign in the multiplication. Okay, you guys ready for another? I'll give you another one to start. You guys solve it and then we'll do it together. This one has 7x plus 3y equals negative 5. And we're going to have negative 14x minus 6y equals negative 10. Pause the video and go ahead and solve that. Okay, I'm going to assume you did. I don't know which variable you chose to eliminate. For me, they both are equal and opposite, or not equal but opposite, but they're both opposite. The y has a smaller coefficient, so I'm going to focus on the y. And 3 and 6 are multiples of each other, or 6 is a multiple of 3. I don't need to multiply both sides by 3 and 6. I can just multiply this equation by 2. If it makes you comfortable, put 2 on each side like that with parentheses like that. Then I get 2 times 7x is 14x. 2 times 3y is 6y. And negative 5 times 2 is negative 10. Then I add them up vertically. The x's eliminate and the y's eliminate. We have 0 on the left side. Negative 10 plus negative 10 is negative 20. What does that mean? That's never true. What's going on here? Let's edit our equation, make some new lines here. 7x plus 3y equals negative 5. And negative 14x minus 6y equals negative 10. Look at that. The lines never cross, do they? These lines are parallel. Which means they never cross. And that means there is no solution that solves both equations. One second. And they call this an inconsistent system. Let's find that right. Inconsistent system. I'm not big on that terminology. There's just no solution. The lines are parallel. Okay. So let's take a look at another option. Negative 9x plus 3y equals negative 24. And we're going to have 3x minus y equals 8. Go ahead and solve that real quick. Just got a text. Let's see if it's from one of the students. And I can answer a question in class. Nope. All right. So, did you guys solve it? So again, the y's have the smaller coefficients. It looks like if I multiply this one by 3 on both sides, 3 times negative y will give me negative 3y, and that'll cancel out the y's. 3 times 3x is 9x, and 8 times 3 is 24. And when I add vertically here, I get 0 equals 0. Everything cancels out. What's going on here? Let's take a look. There's my first line. Wait a second, what happened? Can you guys see that? I turn on the red line and it completely covers up the black line. These are the exact same line. So when lines overlap like this, every solution on one line is a solution on the other, or every solution for one equation is a solution for the other equation. And when this happens, this means there is an infinite number of solutions. And the way what they call this is they call it a dependent system. Okay. That's the technical jargon for that one. For me, infinite solutions on the line is a good answer. No solutions for this one up here is a good answer. So no solutions a good answer. Infinite solutions on the line is a good answer. When there's just one answer, it's called a consistent system. Okay. Notice what would have happened if I had done this. Divide by -3. If I do that, -9 divided by -3 is +3. 3 divided by -3 is -1. And -24 divided by -3 is +8. It's the same line. Okay. So that was too easy. Let's kick it up a notch. Go big or go home, right? Let's go big. All right, so the next thing is when we have 3 variables. So let's call equation A 3x plus 9y plus 6z equals 3. B we'll call 2x plus y minus z equals 2. And C, x plus y plus z equals 2. Now, this is a system of 3 equations with 3 unknowns. Or 3 variables. These are equations of a plane, as you'll see when you start doing 3D work if you go far enough down this math branch. We tend to use z for the 3rd dimension. Now, it's important to know this is true for any system. For a system to have a solution, a unique solution, there must be as many equations as there are unknowns. You could still end up with no solution or infinite solutions, but for it to have a solution, there must, if you've got 3 variables, you need 3 equations. If you've got 5 variables, you need 5 equations. Now, strategy for solving these. So, strategy. The first thing you want to do is combine different pairs of equations via the substitution method or addition method. And you want to use different pairs. What this does is this gets you down, and you're going to do it in such a way that you end up with 2 equations with 2 variables. So eliminate one of the variables in this process. Okay. So let's do that here. I'm going to start on another page. So pause it, write down the strategy real quick, because I'm about to cover it up so we can keep our equations up top. Okay. So what am I going to do? How can I combine these? What might be an easy way to combine them? So I'm going to look at these equations and go, what variable looks like it's the easiest to get rid of? Now, equation C, all of the variables have a coefficient of 1. So they're all viable there. Equation B, 2 of them have a variable of 1, positive or negative 1. So I'm going to focus on one of those, Y or Z. I'm going to choose Z, first off, for 2 reasons. Z already has a negative sign in one of the pairs. And for the third equation, Z has a smaller coefficient than Y. So let's focus on Z. And label your equations like I did. And write down what you're combining to track your work. So B and C look like the easiest to combine at first. B plus C. That's what I'm doing here. So I've got 2x plus y minus z equals 2. X plus y plus z equals 2. And when I add them together, I get 3x plus 2y. The z's eliminate, and I've got 4 on the right side. Now I want to use A. Now I need to use A. I have to use A. So I'm going to use A, and right now A's got a coefficient of 6. B's already got a negative sign, so if I multiply B by 6, I should end up with a negative 6C. Do you guys see that? So multiply b by 6 to get negative 6c. So that's what I'm doing here. And then I'm going to add those two. So I'm doing a plus 6b. A is 3x plus 9y plus 6z equals 3. My 6b portion is right here. 6 times 2x is 12x. 6 times y is 6y. 6 times negative z is negative 6z. And 6 times 2 is 12. I add these up, and I get 15x plus 15y equals 15. Now I want to work with these equations. Do you notice that this one has all 15s in it? If they all have the same, like if they're all identical, it's even easier. But if they're all multiples of a single number, we can simplify the equation. I can simplify this by dividing everything by 15. Divide both sides by 15. And this line turns into x plus y equals 1. Now I have some options. I can either use the substitution method, because this has a coefficient of 1 on both of them. And we're working with these two now. These two work here. So substitution method works, or the addition method. It's easy to multiply this equation by any number we want, right? I don't know. Take the pick of what you like. I think the elimination method works the easiest. Let's get rid of the 2y. Well, no, let's get rid of the x. Why not? Let's do the x. In the notes I had before, I got rid of y. Let's get rid of x. So I'm going to multiply by negative 3. And I get negative 3x minus 3y equals negative 3. So here, let's just call this D. We've got 3x plus 2y equals 4. And negative 3x minus 3y equals negative 3. I add vertically, the x's eliminate. I get negative y equals 1. And if we multiply both sides by negative 1, we get y equals negative 1. Okay, now work backwards. Work backwards to find the other variables. Work backwards to find values for the other variables. I had x plus y equals 1. I'm going to plug that in, and I get x plus negative 1 equals 1. I'll add 1 to both sides, and I get x equals 2. And now I just need to find z. Pick one of the original equations for the final value. You can pick any of them you like, but I think working with C here had the least number of coefficients. So I get x plus y plus z equals 2. X here is 2. Y here is -1. This combines to 1 plus z equals 2. We subtract 1 from both sides, we get z equals 1. The solution is written in terms of x, y, z. X was 2, y is -1, z is 1. This is called an ordered triple. When there's 2 of them, it's called an ordered pair. This is an ordered triple. Okay. So let's just look at this. Let's check our work. So we had 3x plus 9y plus 6z equals 3. We had 2x plus y minus z equals 2. And we had x plus y plus z equals 2. And our solution was x, y, z equals 2, -1, 1. I'm going to check each one of these. 3 times 2 plus 9 times -1 plus 6 times 1, does that equal 3? This is 6 minus 9 plus 6, does that equal 3? 6 minus 9 is -3, -3 plus 6 equals 3. Check. That one worked. Pause this and check the other two yourself real quick. This is good practice. Okay, I'll assume you did. We've got 2 times 2 plus -1 minus 1. Does that equal 2? 4 minus 1 does equal 2. And the final check, 2 plus -1 plus 1, does that equal 2? And the -1s cancel, and we get 2 equals 2. That one works as well. This one's not so easy to illustrate in Desmos because Desmos does 2-dimensional surfaces and a plane is 3-dimensional. And when you start actually working with them, they are a pain in the butt to draw. It takes work. It takes practice, not work, practice. All right, you guys ready to try one? Your turn. You try. So A is going to be 3x plus 4y minus 2z equals 14. B will be 2x plus y plus 2z equals -9. And C is x minus y plus z equals -9. I will tell you the solution. That way, when you work through it, you know you got it right. -2, 3, -4 is the solution. Pause the video and go ahead and work that out. Okay. So let's see, what do I think is a good one to work with here? I think getting rid of the z's is kind of easy. So if I do a plus b, three x plus 2x is 5x, 4y plus y is 5y, and my z's go away, and I get 14 minus 9 is 5. And now I need to work with c as well. If I'm going to get rid of z's, I need to multiply this by 2. So I'm going to do a plus 2c. Maybe I'll write this out because they're not already written as r. So we've got 3x plus 4y minus 2z equals 14. 2 times c is 2x minus 2y plus 2z equals negative 18. And now when I add them, I get 5x plus 2y equals negative 4. Okay. This one looks like it cleans up pretty well, right? I can divide by 5 here. And I get x plus y equals 1. So let's do, I don't know, let's multiply this by negative 2 that will get rid of y's. Negative 2x minus 2y equals positive 2. And I add, I get 3x equals negative 2. Something's off. Did I do something wrong here? Yeah, that's positive 1, not negative 1. What am I doing? So this should be negative 2 over here. This is negative 6. Divide by 3, and I get x equals negative 2. Now, the reason why I didn't stop and double check my work because I knew the solution already. I wasn't even paying attention to that. I had 3x equals negative 2, and I was going to end up with a fraction. And rather than trying to work through with a fraction, I'd go back and make sure I did something right, because I'd rather recheck my steps and look for an error and end up with an integer rather than working with fractions. And now I've got that. X equals negative 2. I put that in there. And I get y equals 3. And if I put that in C, negative 2 plus minus 3 plus z equals negative 9. Negative 5 plus z equals negative 9 leads to z equals negative 4. And we have the negative 2, 3, 4, just like I had said earlier. There was actually an easier way to do this. It doesn't always leap out at you. So if it does, you can save yourself some work. Check this out. B and C, the X's and Z's, have the same relationship. This is X, this is 2X, this is Z, this is 2Z. What if I did b minus 2c. My b is 2x plus y plus 2z equals -9. -2c, what does that get me? -2 times x is -2x. -2 times -y is +2y. And -2 times z is -2z. And -2 times -9 is 18. And when I add these vertically, two variables go away. I get 3y equals 9, y equals 3. Plug that into all beginning, plug into each of the first three equations. And now you're down to two variables. And you can pick where to go from there. Solving for two variables is less work than solving for three. What else is this good for? Find the equation of the parabola given 3 points on its curve. A is going to be -5, 7. B is going to be -1, -2. C is going to be 3, 5. Let's just set it up and not solve it unless you want the practice. Parabolas are quadratic equations. This is quadratic. Y equals ax squared plus bx plus c. If I plug in the 3 points, separately, we get 3 equations of A, B, and C. The y's and x's go away, but we have A, B, and C. And this is what I mean. Let's plug in A. Each of them I'm plugging into here. So -5 is my x, y is 7. -5 squared is 25. I get 25a minus 5b plus c equals 7. -2 equals a times -1 squared plus b times -1 plus c. -1 squared is 1. I get a minus b plus c equals -2. And we do c, 5, 3. My 3 is my x, it gets squared, and we got b times 3 plus c. 3 squared is 9. I get 9a plus 3b plus c equals 5. 3 equations with 3 unknowns. We can solve, and once you have given a, b, and c at the end, plug into y equals ax squared plus bx plus c. That's how you can get the equation for a parabola given 3 of the points. Okay. One more idea in this section. Let's look at this system. 3x plus y minus 2z equals -7. 5x plus 2y plus z equals -6. And c, -6x minus 2y plus 4z equals 14. What this makes this unique is what happens here. Notice what happens if I multiply by -2 on a. -2a is -2 times 3x is -6x. -2 times y is -2y. -2 times -2z is +4z. And -2 times -7 is +14. This is C, equation C. They are the same plane. The only options we have here is the planes can, if B overlaps them also, if B overlaps as well, they are all the same plane. We have infinite solutions on the plane. This is an awkward way of saying it, but if B is parallel, we use the word parallel to describe lines, but let's just say 2 planes that are equally spaced, like cake layers. There's no solution. And the only other way 2 planes can cross, option 3, they can cross in a line. Like having, see if I can do this very well. That's not a very straight plane, is it? Pretend this page goes all the way through the other one. They're making a line on this seam right here. Okay. So let's add B and C together. Let's do B plus C. Let's see what happens. If they're the same plane, it'll end up going away. But we can see the 2y and -2y they cancel. But 5x minus 6x is -x. Z plus 4z is 5z. And -6 equals 14. Or plus 14 equals 8. I'm going to get x by itself. So I'm going to add x to both sides, and I'm going to subtract 8. And I'm going to get x on the right equals 5z minus 8. Okay, let's plug this into the other ones. So into 8, I have 3 times 5z minus 8 plus y minus 2z equals negative 7. If I distribute, I've got 15z minus 24 plus y minus 2z equals negative 7. I can combine z's and I can add 24 to the other side. And if I do, I get y plus 13z equals 17. So y, if I subtract 13z, I get y equals negative 13z plus 17. My line the xyz is now a function of z. If I plug these in, x equals 5z minus 8, negative 13z plus 17, and z is z. So plugging in different values for z, gets you different points on the line. Of intersection. Okay, that wraps up 9.1. I'm going to do 9.5 next. It's really brief. Okay, peace.